Okay, so we have hemostasis, which means stoppage of bleeding, right? Where the body tries to put in mechanisms through which blood will stop leaking out of the blood vessels. Because initially, blood circulates through uh, inside of the blood vessels. So we call it intravascular fluid, right? Inside of the blood vessels. So the thing is that what happens is that if there's injury to the blood vessels, blood starts coming out, platelets come to the area, platelets come to the area. So in cases of thrombocytopenia, where the platelets levels are low, then you notice someone bleeding, right? So aside from the platelets coming to the area of injury, you will find that there is a need for the formation of fibrin. Okay, fibrinogen has to be converted to fibrin. Fibrin, this is simply a mesh network like material that is going to stabilize the clot, that is going to help in the same clot formation, stabilize it. Okay, so these are the clotting factors for us to form the fibrinogen, for the fibrin, which is clotting factor number 1, has to be converted to fibrin. So they simply cascade. There are simply two pathways that we talk about. There's intrinsic pathway and extrinsic pathway. But let me just run you through the names of these clotting factors. So we have factor 1, fibrinogen, factor 2, prothrombin, factor 3, tissue thromboplastin, factor 4, calcium ions, factor 5, Labor factor, factor 7, stable factor, factor 8, antihemophilic factor. Factor 9 is called Christmas factor, or it's also called plasma thromboplastin component. Factor 10, start power factor. Factor 11, plasma thromboplastin antecedent. Factor 12, Hagman factor. Factor 13, fibrin stabilizing factor. So in the next session, what we are going to discuss now is how these clotting factors try to activate each other, then in the end forming a mesh network, which is called fibrin. Thank you so much for watching.